The formal definition of a functional dependency is this. Whenever you have A determines B, where A can be a collection of attributes and B can be a collection of attributes, then what is the real meaning is this one. See, let us say there are two tuples T1 and T2 in the table, and this is a collection of A attributes and that is collection of B attributes. If T1 and T2 agree here, which means if T1 and T2 are having same values in A, then they must have same values in here, then only insertions will be possible, right? And if T1 and T2 disagree here, which means if T1 and T2 are having different values for A, then they may agree or disagree here. So what I mean to say is, let us say that particular functional dependency is applicable for a table. When do you think that a functional dependency is applicable for a table? Whenever all the attributes present here and here are also present on the relation schema, then that particular functional dependency has to be applied on every such relation. Okay, so before you insert or delete, or before, generally insertions only, right? Generally whenever you try to update it or modify it, we are going to see that this functional dependency always holds on all the relationships for which it is applicable. Let us say this is the table and there are some set of attributes. Even though I am writing it as if it is two columns, A and B might be two columns, which means might be simple attributes or they might be collection of attributes, right? Now what is that they are saying? If A determines B is a functional dependency you have defined, then definitely on this table whenever A values agree, which means if A values are like this same, then they must agree here also, which means B value should also be the same. So if it is A here, it should be A, right? If they don't agree, which means let us say it is 2, 3, right? And here they may or may not agree, which means either you could have A here or you could have B here. It is valid. Got it? So now if you observe it by defining it this way, right? So if you observe it by defining it this way, what happened is everything here. So for example, A derives B. See this, for a given value of A, a value of B is unique, and in case if it is different, we never check about it. Got it? So functional dependency means it is applicable wherever in some part of the relation. If it is applicable, then wherever you see the left hand side as same, then the right hand side should be same, and if it is different, it is going to be different, right? So why are we going to insert two times the same left hand side? See, it is definitely possible, right? The entire relation as a whole should not get repeated, but a part of it can get repeated. There is no problem, right? And now especially this is going to cause, such entries are going to cause redundancy. Let us say we have one more time 1A, one more time 1A, one more time 1A, right? Now instead of storing at this entire thing in this table, we could have stored it in a separate table simply containing A and B, and then we have only one attribute like this, right? So instead of all this 1, 2, 3, 4, 5, we can have just one tuple, and that one will represent this. The redundancy can be eliminated. So the entire focus here is making every functional dependency applicable to one particular table in which the left hand side is not repeated. See, here the left hand side is repeated because A is not a primary key for this table. Got it? In case if you make it a primary key, definitely left hand side will not get repeated. If left hand side doesn't get repeated, then there will be no redundancy. Redundancy is only when left hand side is repeated, isn't it? See, the rule is this: if T1 and T2 agree, which means if two tuples are having the same value for A, then only we are getting the same values here, then only we are getting the redundancy. In case if we can make it a primary key, how can you make it a primary key? You make it a separate table itself completely. In that table you can make it a primary key. In that you see that all the values of A are different, right? Then there will be no redundancy at all. Okay, fine. Anyway, that is the formal definition of functional dependencies. Okay.